Today we are gonna actually talk about this subtraction rate and then start calculating it. I think that will be best if we can actually do that. What we can do is this. What we are saying is that basically matter basically subtracts the space and time based on Max Planck size per second. So basically, if we have an object here, doesn't matter the size. What it does in all directions is basically subtracting the space, time, and reality.
Just inside, right?
Yes.
Inside.
Basically collapsing time and space
Inside.
inside, yes. So this is, let's say, center of that massive object. Let's say it is a full square. So what will happen? Every second it will basically eat up, we can say that, a certain number of fabricas.
And the new fabricas coming, it's like sync, yeah?
Yes.
It is like
Exactly.
fabricas disappear
Exactly.
on the surface.
Actually, the first time that I thought about that, I was in the bus. So it's exactly the same. Okay?
Three-dimensional sync.
Yes. Now, what you should calculate is this. Mass eating up per second a number. So we don't need C at all because it has nothing to do with C.
There should be some constant.
This is the constant that we are going to calculate. We will come up with it.
Yeah, okay. To compare to what?
Okay, we don't need C because it is quantized eat up per quantity of mass and per second.
The quantity of mass.
And per second. Let's say we have Earth, right? It is 9.9 m. For example, it is 10 meter per second, right? This is the gravity rate, correct? This is the gravity acceleration.
Okay.
What that means? This means Earth, if we divide that meter by Planck size,
Yeah.
by Planck size, we will get a number, a huge number.
So this is like, yeah, okay.
Okay? What will happen is this. We can calculate each direction, each basically, like in all directions, it's going in all directions. Eating up how many Planck size fabricas per second.
So the object accelerates with 10 meters. This is.
Yes, that we will come up with the same number. So we come up with the G at the end of our calculation for sure, because this is how it works. And this G will become lower and lower as the more that we actually have like distance into a deeper space, correct? Because it is going this way, right? Like in all directions we are, like it's eating up, correct?
And principle is that if the fabrica disappear, object accelerates down.
Yeah. Consider this like a funnel. A funnel. Okay, a big huge funnel. What will happen? If we actually taking basically fabricas out, here we will have a slower
motion of metal.
Yes, but here we have faster. This is exactly how it works. And if our theory is correct and we calculate it properly, we should come up with G and a similar G in the orbit when we are having distance from the massive object.
G. So this should be acceleration of the object coming down.
Yes, this is like a funnel, exactly like a funnel. Like let's say we have a funnel, and this funnel basically is eating up Fabrikas, and therefore here we will have less per second because of the orbit, and here we have. So we should come up with such kind of equation. So what will happen? We don't need C at all.
Oh,
We don't need G. We calculate the G out of this.
we just want the acceleration is G or the distance of the Earth.
No, what we can say is this. We can actually like calculate it based on the center for sure, and per second how many Fabrikas this object is. Doesn't matter the radius. Like the radius,
Yeah, is it?
if you compact it to even a black hole, it will eat up the same amount of basically Fabrikas with the same funnel, but this object will be like smaller, like more compact.
Yeah.
Let's say more dense.
Only thing we have to compare that at the distance equal to the Earth's radius, it should be acceleration should be close to G. Yeah, this is how.
Yes, exactly. Like because, for example, we calculate the G here and the
should be
surface.
equal to 9.8.
Exactly.
That will determine the rate of
Yes.
destruction.
And then we can calculate the force. This is a force. G is force, right? We can calculate the force exactly based on that outcome. What is the difference between this theory and like Newtonian theory, or especially Newtonian theory? Each object will be totally independent from any other object in the number of Fabrikas that it can eat per second. So we can calculate how much Earth is eating up Fabrikas in total. Doesn't matter if we have moon here or we have something here. No, we are not calculating based on any other object. We are calculating the total Fabrikas per second that Earth can eat from all of the funnels toward 3D. So what will happen? With calculation, we can come up with the exact dark matter problem, and we can actually show it.
So in this model, Fabrikas disappear just inside mass field body.
Yes.
Right?
Yes.
So this means rate times the volume of this object.
From the mass of the object.
Times the mass or
Yes, mass the object.
mass. Okay, it could be.
But we need one mass in this calculation. We need to, unlike Newtonian, we don't need two mass.
Yeah.
In Newtonian, we need two mass.
That's okay, but I'm not sure how to define rate of destruction. I thought it is rate times volume, or different model is rate times mass. Then volume doesn't matter.
Volume doesn't matter. It is rate on total. It's rate on mass.
Mass. So.
But when you are actually calculating this, like basically the distance from the center,
Yeah.
you will come up with the G in that distance. So now, if we are actually here, we should calculate, for example, for sure the G will be less because we should calculate this space as basically also eating up Fabrikas. And then the funnel, we have a small funnel here and larger funnels here. So we will come up with the exact G even inside there.
What is
like,
funnel? What do you call funnel?
Like funnel is
Think.
like funnel, like when we have, let me actually
Channel for stream.
Yeah.
So it's.
Yeah.
Okay.
Exactly. Okay. The calculation is like pretty straightforward. But for sure it's like a 3D funnel. Okay. So I think we are clear on this how we can. And then we can come up with G between two objects for sure, because if moon is here, it has its own funnel, it's eating up Fabrikas too. Therefore, what will happen? We can calculate it easy.
Once we determine rate of motion of space-time to the center,
Yes.
that will tell you acceleration, that will tell you the force.
Exactly.
acceleration times the force of z object will be the force on z object.
It will be plus. It will actually then we can actually calculate both. We can come up with Newtonian force at the end of the day when we calculate. Yes.
But main thing is I think the acceleration. So because fabricas are moving,
yes,
objects are moving with them.
Yes,
and
exactly.
That is kind of
yes,
attraction.
Exactly. It come up with the G illusion. G is an illusion. It's not a constant.
Oh.
So what we say is G is illusion of basically fabricas getting disappeared in this space, and therefore G is meaningless completely. It is the result of this new equation that we are gonna have. It is not the constant. So G and G are both useless in our system. C also is useless.
So fabricas are disappearing inside the volume?
Yes.
Just inside, yeah?
Yes.
Outside, and what are doing outside fabricas? Then they move? Move inside?
Yes. They basically the framework, the whole space and time getting always disappear.
From all directions.
Let's say yes.
From all directions they
Exactly. Exactly.
And the Z motion is felt by masses outside, other masses.
Why it's felt? It's because the time and space and reality is getting disappeared all the time. Therefore, they feel they are falling. Because that is the feeling that you have, because the basically address of a space and time is always changing, and therefore, because the address of the space and time and reality is changing, you will feel that you are falling. So, in this case, what it says in Newtonian gravity, it says basically apple falls. Apple falls, therefore this is the force. In general relativity, it says earth falls to apple and apple falls to earth. In this, what we say is that nothing is falling. What is happening is that basically the framework, the space and time is getting disappeared all the time by gravity, that is called gravity, and therefore the address of the object basically is changing, accelerating toward, because the space and time is getting eaten up by and any object in that will actually will feel the acceleration toward. Yes. So that is the feeling, but it is actually this the destruction of the subtraction of the space time and reality. Now, what is important in this model? We don't need the second object at all. This is working. Doesn't matter if there is an object or no. The second thing is we don't need G and G. We come up with G and G as the result
of motion of fabric.
Yes, as the result we can calculate G and G. So it is basically the basis of that. And the most important thing, the gravity is a cumulative thing. What that means, it doesn't matter if we have other objects or no. This is working for eating up space and time all the time. Therefore, it is accumulative. It's not depend on R2, which is basically Newtonian model, and it works like that. Now, it is accumulative. For example, let's say we have galaxy full of these objects, full of the matter, full of the mass. And what happens? The calculation that we are going to have, we have a very different system in the galaxy, because all of the matter are eating up particles all the time, accumulative. And this is what we see around the galaxy as the shadow of dark matter. And this will be the result of total gravity, called gravity, total subtraction of all matter. This will be the result. But in Newtonian, it is this.
But in Newtonian also, the total mass inside, they act together to attract outside.
But it is R2. So their distance together, yes, their distance in distance, it will be very different than this.
like a 1 bar square. It
Exactly.
goes too fast, you say.
Yeah, as the more basic the distance that they have with each other will exponentially reduce the gravity.
So you say in this model it will fall slower.
It is not going to fall slower because still we have R2 here, okay?
1 bar square.
Yes, we have R2 when we want to calculate, it is going to actually follow the, but in a very like large system, what will happen, the whole gravity in the system should be calculated based on all of the mass, for example, let's say in galaxy, and each one independently eating up the fabricas. Therefore, the calculation will be very different in the galaxy size system. Because in galaxy, the distance is very like large, but the calculation when you do it based on this system, it will be the total loss of fabricas per second of that galaxy. So this will be the system, because it is not each object to each object, and this object to this object, and this object to this object, and then this to this, and this to this, and this to this. It will be this, plus this, plus this, plus this, plus this, the total fabricas that they are eating per second. So this calculation will be different, very different when R2 is very like large number. This calculation will define the dark matter, and we can even come up with a very precise number when we can calculate Earth is eating up how many fabricas per second. So we have a new constant. What is the new constant? Earth alone is eating up, for example, X amount of fabricas per second.
So what we want to, what is the unit of mass, 1 kilo, how much it is fabricas? It's
Exactly.
this is
1 kilo of mass, or what we can do, we can actually use the Planck minimum mass let's use that as the standard. We have, I think it is how many kilos multiplied by 10 power by minus 8. Yeah, we can use that, okay? And then we can say, okay, this much of mass will eat up this much of fabricas per second. That's it. And then we can come up with Newtonian model, pretty easy calculations. We can come up, it should result to G. Newtonian model will be the result of this. Funnel, eating up fabricas, therefore this R2 is here. And what is gonna happen? We are gonna have a new constant as the gravity. We define a new constant. We remove G and G completely from the calculations, and it will solve a lot of problems. We can come up with the dark matter, pretty easy. And then we can actually publish the first paper about the gravity.
This line, is it the G inside the object or inside
Which
the,
line?
This line? Is it G as a function of R? This line, Newtonian.
This one?
No, the upper one. Yeah.
This is our model.
G is a
This is
proportional to
Fabrik
R.
model. Yes, this is in large distance because R2 will be too much. Like when we are actually like when we are talking about the distance, if distance is like really long, it is becoming zero. The force almost becoming zero. It's becoming irrelevant.
Is a 1 bar square.
Like let's say two objects are very far from each other. What will happen because you are dividing that by R2? This Newtonian model will be totally irrelevant because this R2 will make it almost zero. So in large distance, what will happen? In large distance, the gravity based on Newtonian model
Is weak.
is very weak, and you can consider it irrelevant. Now, in our model, we are not considering anything irrelevant. The total fabricas that a galaxy uses, eats up every second, remain the constant.
So you say in our model G as a function of R will be not 1 bar square, but
Yes.
it will go slower down, yeah?
Yeah, in the distance, it has a very
Different power. Yeah?
different power. And when we have this number, we can easily calculate it and come up with the dark matter model. So basically, I'm gonna explain again because it's extremely important. We are gonna define a new gravity formula. This gravity formula will not need G. G is the result of this formula on the new constant that we are defining. Will not need C, because what we are saying is the quantized this is the object, and this object from all directions
Fabrik.
eating up fabricas of space, time, and reality. So basically we can consider the object and the rate of basically fabricas eating up fabricas as the total we should say fabrica eating power of that mass. It doesn't matter if you have another object here or here or here, it doesn't matter. This will eat up certain amount of fabricas every second. And this will be the basically answer to the dark matter. Because in this system, you will have funnels here. Just consider virtual funnels. It will work exactly like Newtonian model, R2, okay? But in a very large system, like a galaxy, this R2 will make it irrelevant, like almost irrelevant. It will not come up with it will not bring the correct calculation. But in this model, each object will eat up certain number of fabricas. Therefore, in the galaxy system, in the whole basically calculation, all of these objects will eat up certain number of fabricas per second, and therefore it is accumulative. It is not based on R2 of different objects toward each other. So if we want to calculate the whole gravity
of, let's say, five masses.
Yes, 5 masses. The calculation will be in total. If you consider the cloud, a cloud that is a dark matter cloud, what will happen? The dark matter cloud, the total gravity, again I'm putting it in quotation because gravity is like really not a good term for this. The total gravity will be way more than calculating each object towards each object based on their distance. Because each one, like a sink, like a vacuum cleaner, is eating up all the time. And therefore, the total calculation will be different from calculating each object toward the other one. And then basically put it in an equation. So this will create a good make sense of dark matter. Okay, thank you.